Dear fellow scholars, this is 2-Minute Papers with Károly Zsolnai Fehér. Today, we are going to talk about the craft of simulating rays of light to create beautiful images, just like the ones you see here. And when I say simulating rays of light, I mean not a few, but millions and millions of light rays need to be computed alongside with how they get absorbed or scattered off of our objects in a virtual scene. Initially, we start out with a really noisy image, and as we add more rays, the image gets clearer and clearer over time. The time it takes for these images to clean up depends on the complexity of the geometry and our material models, and one thing is for sure, rendering materials that have multiple layers is a nightmare. This paper introduces an amazing new multi-layer material model to address that. Here, you see an example where we are able to stack together transparent and translucent layers to synthesize a really lifelike scratched metal material with water droplets. Also, have a look at these gorgeous materials. And note that these are all virtual materials that are simulated using physics and computer graphics. Isn't this incredible? However, some of you fellow scholars remember that we talked about multi-layered materials before. So, what's new here? This new method supports more advanced material models that previous techniques were either unable to simulate or took too long to do so. But that's not all. Have a look here. What you see is an equal time comparison, which means that if we run the new technique against the older methods for the same amount of time, it is easy to see that we will have much less noise in our output image. This means that the images clear up quicker and we can produce them in less time. It also supports my favorite, multiple importance sampling, an aggressive noise reduction technique by Eric Veitch, which is arguably one of the greatest inventions ever in light transport research. This ensures that for more difficult scenes, the images clean up much faster and has a beautiful and simple mathematical formulation. Super happy to see that it also earned him a technical Oscar award a few years ago. If you are enjoying learning about light transport, make sure to check out my course on this topic at the Technical University of Vienna. I still teach this at the university for 20 master students at a time and thought that the teachings shouldn't only be available for a lucky few people who can afford a college education. Clearly, the teachings should be available for everyone, so we recorded it and put it online, and now everyone can watch it free of charge. I was quite stunned to see that more than 10,000 people decided to start it, so make sure to give it a go if you're interested. And just one more thing. As you are listening to this episode, I am holding a talk at the EU's Political Strategy Center. And the objective of this talk is to inform political decision makers about the state of the art in AI so they can make more informed decisions for us. Thanks for watching and for your generous support, and I'll see you next time.